All right, we have a question and it says the 3.75 kilogram physics book shown is connected by a string to a 470 gram coffee cup. The book is given a push up the slope, and we're going to call this direction positive. So this is going to be that direction. It's going to be positive. And released with a speed of 1.71 miles per second. The coefficient of frictions are the coefficient of static, which is 0.466, and the coefficient of kinetic, which is 0.344. Now, I'm going to start off by naming these objects. This is going to be object 1, and this is going to be object 2. Now, let's start off with object 2, okay, because this one is easier. This only has the Fy, the summation of F, which is all the forces, is only going to be in the y direction. So it's just the force of tension right here. And then the other force that's going to be acting upon it is gravity. So gravity and tension, and that's it. So it's force of tension, which is pointing up, minus m2g, okay? Because we're calling this block 2, it'd be m2, and this would be m1. And so that is our entire kinematic equation for the second cup. For the first cup, it's going to be a little bit different because we have to break this one up into the summation of Fy, which is the total force in the y direction, and that is going to equal to 0, just FYI. But as for an actual equation, it's going to be the force, the normal force, minus m1, right, because we're talking about mass 1, gravity, and then cos theta. We're doing cos theta because you have to remember that this is on an incline, and we have this theta right here that we're going to have to use to be able to find the actual amount of y directional force. Now our second equation, and I'm going to go under here, is for the same block 1, is going to be the summation of fx, and please pay attention here because this one's going to get really long. This one's also equal to ma, we want to remember. And then this one is actually also going to equal, and I'm going to go all the way down here, okay? We have the negative negative tension, because if this way is positive, then this way is negative, and that's the way the tension is pointing. We're going to have a negative mu k, which is the kinetic friction, times the normal friction. And if you guys don't know what that is, then that is, we know the equation Fs is equal to the kinetic friction times the normal force. Okay? And then we also need to subtract m1 g sine theta. And now you might be wondering, why in the world are we using this sine theta? It's because when we look at these different directional properties, we need to understand that this right here has to be a factor of sine or cos theta because we're on an incline. Now, this is the equation that we're actually going to be using, because if we look at it, we are trying to find what? Oh, we are trying to find the acceleration. I don't see an acceleration in either of these two forces, but I do see an acceleration right here, right here. So we're actually going to be using acceleration, this very equation to figure out the acceleration. So our new equation is going to look something like, and I'm going to change my color into something pretty. ma is equal to, right? We know that the force of tension can be broken down to be m2g. We know that we have to do the force of the normal force is going to equal mu k, because this together is the force of friction. Friction, I forgot the F. Okay, it's the force of friction. We're going to have to multiply it. Usually the normal force is mg, but because we're on an incline, we have to do m1g, I forgot what block we're working on. M1g cos theta, because again, we're on an incline. And then we're going to be subtracting m1g sine theta. Now, to be able to find the actual A, we have to remove the m. And just to be clear, this is the mt. Mt means total mass, which just means it is m1 plus m2. Okay, now you will get this equation. I'm just going to simplify. You will get A is equal to negative m2g minus mu k m1g cos theta minus m1g sine theta. I should have just copied it from the top anyways, and then you're going to have m1 plus m2. And that should be the equation to solve for acceleration. Now, the second part of this question, I'm going to move this up because wrong place. Okay. The second part of this equation asks us, how far does the book slide before it has a zero speed? We can use our kinematic equations, again, believe it or not. So we already have our A, which actually we found right here. You're going to use the exact same value down here. So A is going to equal, and I'm just going to leave it, your answer. Okay? That's what A is going to equal. And then our VI is going to equal whatever number they gave you up here, okay, which for me is 1.71 per second. And then you're going to have your V2 or your VF, which is going to equal 0 because we want it to have a 0 speed. Now, we can use actually a kinematic equation right here. We know that we have the kinematic equation V2 squared minus V1 squared is equal to 2a, and then they have x minus x naught, which is the same thing, 2a delta d, which is a displacement. And then if we were to rearrange this equation, then we would get it to equal delta d, because that's what we're trying to isolate for, is equal to negative initial velocity squared divided by 2a. And then you can solve your equation and you should get, depending on your numbers, anywhere from 0 point something to 1 point something meters. You go ahead and put that answer, and that is how to solve this question.